Okay, gang, Dr. Darbro. This is the second video of the third video on calculating type 2 errors. And let's just start out with a simple problem. Let's say that the null is we're testing the claim that the mean of a population is equal to 50. And the alternative is we're testing the mean greater than 50. And we're doing so under the criterion that the significance level of the test is 0.05. And that the population standard deviation, sigma, is not known, which is, typically the case. Well, the first thing we'd want to do is we'd want to go out and collect a sample. And let's say, for the sake of this sample, that we decided to collect measurements on 35 people. And after analyzing the data, we see that the sample mean for these 35 measurements is 52.8. And the sample standard deviation is 11.2. Now, what we want to do here is we want to calculate the probability of committing a type 2 error if the true mean is equal to 55. We also want to calculate the power, which turns out to be a very easy calculation once we get the type 2 error. Remember, gang, that beta is the probability of committing a type 2. So ultimately what we're doing here is we're calculating beta. And power is just 1 minus beta, which clearly, if we know beta, we can subtract it from 1. Alright, so let's model the problem and let's see exactly what's going on here. Now, what I'll have to remember in setting up this problem is I need to understand, I need to appreciate, if you will, the sign in the alternative hypothesis and the impact that that has on us making our decision. So what I'm going to do in this situation right here is I'm going to realize that my distribution of sample means, which I'll make my decision from, which has a mean of 50, has a rejection region up here on the upper end because of the greater than of 0.05. So the first thing that I want to do is I want to be able to find the values for the line in the sand. In other words, what's T critical value separates the, we should know by now, this is the reject region, and this is the fail to reject region. So what t-score, what t-critical value separates the fail to reject and the reject region, and also what sample mean separates the reject and the fail to reject region. Alright, so guys, here's what we do first of all. The first thing we'd want to do is we want to find t-critical. And we would do that in our calculator by going inverse t. 0.95 degrees of freedom, I'm sorry, not 0.34, but 34. Now, why do I use 0.95? Well, if I go back to my drawing, inverse t and inverse norm always want percent below. Well, I know if 5% of my region is in the reject region, then I've got 95% that's missing. That 95% clearly has to be below. So when I put this in my calculator, I get $1.69. And actually it goes on out. All right. Now, the next thing I need to do is I need to find the sample mean that corresponds to this. Well, gang, I know that my T critical, or a t-score if you will, can always be found by taking x bar minus mu over the standard deviation divided by the square root of n. So if I put in the proper numbers, I'm going to end up getting keep ourselves honest here and put things in parentheses. Okay, so the very first thing I'd want to do is I'd want to multiply both sides by 11.2 divided by the square root of 35. Okay, that's going to be cool over here because that goes away. Now I'm going to do this on my calculator. So I'm going to multiply this times 11.2 divided by the square root of 35. And on the left hand side I get 3.20 and some stuff. Now what I'm left with on the right hand side is just x bar minus 50, so equal 3.2. So gang, obviously what I need to do now is add 50 to both sides. So the x bar that separates the line in the sand is 53.20. So I've got a T critical of 1.69, I think, right? Let me make sure. Yeah. And a sample mean that corresponds to that of 53.20. So guys, what we can do now is we can brush up our drawing a little bit better. So if we're testing a mu of 50, the line in the sand, and I'm going to come in here and do this in yellow. Can you guys see that? Yeah, I think you can see it fine. So the yellow is the reject region. And what separates the, let me do this out a little bit. What separates the reject and the fail to reject region is a T critical of 1.69 and a sample mean of, I forgot, 53.20. All right, so really all we've done right now is we just set up the problem. Based on testing that in the null hypothesis that the mean value of the population is equal to 50, and we're testing 0.05, and we're testing an alternative of greater than, meaning we put all of our rejection region in the right tail. So the line in the sand, if you will, is a T critical of 1.69 and a sample mean of 53.20. Now, the next thing we do is kind of cool in that we come in and we look at the true distribution. So this is equal to the hypothesized distribution, but the problem says, well, what if the true mean, so I'm just letting that be T sub mu, So the true mean, true mu, is equal to 55. Calculate the probability of a type 2 error. Alright guys, the first thing we got to do is we've got to come in here and make heads or tails out of which area, and I'm going to do this in red, which area represents a type 2 error. Now, guys, you can't do this without referring back to the definition. And the definition of a type 2 error is we failed to reject a false null. We failed to reject a false null. Now, the first thing you've got to appreciate and understand is that all, and that's not going to work. It's not going to be dark enough there. Let's try to come up with something stands out a little bit more. Yeah, let's just go with yellow. That seems to work. All calculations are going to be made on the distribution with a mean of 55. Why? What's the true distribution? That's what we're calculating the type, the probability of a type 2 error on. We've tested mu equal 50, but what if the true distribution is 55? So now we have to focus totally on the distribution that's centered at 55. Now, focusing totally on the distribution of mean equal 55, where would a type 2 error fall? Well, it should be, and I want to differentiate this with a different color, and I really can't find a color that suits me. Let's try this one. It should make sense to you or maybe not, that part of the area under the curve represents a type 2 error. Now, someone tell me why. I know that's a rhetorical question because you can't talk to me, or maybe you have been talking to me. Maybe I don't know what you're telling me, but why is it a type 2 error? Well, a type 2 error is failing to reject a false null. And if we got any mean from this line back, we would get the false impression that we were drawing from this distribution when indeed it is false. But the calculation of our error has to occur in this distribution because that's the distribution we're truly drawing from, because that's the true distribution. So with this distribution right here, anything to the left of this line would lead us to believe we're residing over here, when indeed we're really in this distribution right here. So guys, what we need to do now is we need to come in and think about this part of the curve. That was blue, corresponding to this part right here. Well, what do we know about that? Well, we know that in the distribution with a mu equal 50, well, I'm just having one heck of a time here, aren't I? Let's try that. So with the distribution when the mu is equal to 50, this line in the sand right here had a t critical of 1.69 and an x bar Well, gang, this is driving me insane here. I can't handle this. I think 2 actually works best. Let's try that. And an x bar equal to 50, what was it, 53.20, I believe it was. So 53.20. What good does this do us? Nothing. Tell me why. Well, then doing good, because that's the location in terms of standard errors in the distribution mean of 50. But we're doing all of our calculations now in the mean of 55. So what do we need to do now? We need to find the new critical value for the mean of 53.20 in the distribution with a mean of 55. With that standard error. Now, I haven't left you. All I'm doing, I grab my calculator and doing some calculations here. So this gives me negative 0.95. So that tells me that the sample mean of 53.20, which had a t-score, or t-value, if you will, in the mean of 50 of 1.69, now it has a t-critical of negative 0.95. So back in this distribution, in the mean of 55, the sample mean of 53.20 is 0.95 standard errors below the mean. Now, how does that help us once all the smoke clears? Well, we had to have that or we couldn't work the problem. If we're wanting to find the area of the blue part with a mean of 55, then we had to find its t-value. Because, well, guys, when we put in TCDF, we have to use the t-value. So guys, believe it or not, we're finally just about there. So calculations of a type 2 error, which is beta, we would use TCDF minus E99 negative 0.95 comma the degrees of freedom of 34. Alright, so let's put that in our calculator. So negative E99 negative 0.95 comma 34, and we get 0.1744, which is equivalent to 17.4% of the time you will commit a type 2 error if the true mean is 55 and you're testing the claim that the mean is equal to 50. We know the power is 1 minus beta. So 1 minus 0.17 is 82.56. Well, 0.8256. Which is 82.6%. This tells us Alright, so this tells us that there's a 0.83 probability of rejecting a false null, namely 50 in this case, when the true mean is 55. So, typically a line in the sand on research is people like to have a probability of 0.8 or higher, like to have a power of 0.8 or higher. So this would actually do the trick. Alright gang, that's the end of video number 2. And I'll post video number 3, which in just a second. Alright, take care.